So terms that you've probably heard before is going to be the scientific method, which is just a systematic approach to solving problems. So sometimes we will go through and we'll make an observation in class, and then I'll say, okay, how can you test it? And then you'll have to come up with your experiment and then take a look to see what that actually kind of gives us. So as we move through this whole year, you're going to be using the scientific method, sometimes in a really simple way and sometimes in a really complex way, especially as I start to introduce some of our variables and how we can use different types of algebra. I know that kind of scares students sometimes to kind of help us, but we will use some math to kind of help us come to conclusions and come up with proper reasons that maybe this is why this happened when we did this in X and Y and Z. So most of the time with scientific method, you make an observation first, and then you come up with a hypothesis, which is just a testable prediction. You conduct an experiment. Sometimes you have to say, oh, I need to revise it and run it again, and then come up with a conclusion. And then that leads us into many different things that we'll talk about in this class. Over and over and over again, if we keep processing the same things, sometimes we come up with the same results, and that results in something becoming a scientific law, something that's normally naturally occurring, whereas a theory is more of an accepted idea that hasn't completely been proven just yet. So we will talk about a lot of scientific laws, and then we'll also talk about theories and how they've evolved even since I've started learning about them way back 20 something years ago. So here's the two terms that we are mostly going to be focusing in on. You'll hear me say these terms all the time throughout this class: qualitative and quantitative. So these two terms, star them, write them down, put them at the beginning of your binder, whatever it may be. So you'll hear me say these words a lot because it's going to give us two different types of measurements that we can use to help us understand the data that we're collecting, what is our evidence that we are going to be using. These are our evidence, our qualitative evidence and our quantitative evidence. So qualitative evidence is just no number involved, meaning that it's some type of description. The car went fast down the ramp. The marble ran into the wall and stopped, or the marble ran into the wall and bounced back. When we created the roller coaster, the marble was able to move at first really fast with a high velocity, and then towards the end it slowed down. Verbal words are going to be qualitative, giving me some type of just description. Quality. I always think quality. Give me some meat to what you're trying to describe. Whereas quantitative is going to be, this is where our algebra and our measurements come in, is our quantitative, is that we are going to get measurements, meaning there has to be some type of numeric number with it. So if I were to say, how long is maybe the blackboard behind me, you would measure that out with a meter stick and say it is 72 centimeters. We want to make sure that we always give our measurement that we're using behind it too. So this one here, measurement of water, it's 67 degrees Celsius. If I just wrote 67 down, the water is 67, that doesn't give me enough information. So we always want to make sure that we are giving proper measurement to numbers. And so you'll hear me say a lot of time, no naked numbers. And what I mean by that is that I want the measurement behind it, whether it be in the metric of meters, centimeters, kilometers. It could be kilograms with our weight. We could be looking at volume, whatever it may be. Make sure that there's always some kind of numeric number behind it. Oops, I went too far. There we go. So hypothesis, again, kind of already talked about this a little bit, and this is probably the one term that I feel like students always come to me like, I know what a hypothesis is. It's an educated guess. Kind of, but there's more behind it than just that, is that you've observed something and now you're going to research it. So I want you to think of it as a little bit more just like, I think the sky is blue. Well, we've observed the sky is blue. Now let's figure out why is it the sky blue? Is it because light is coming through our atmosphere and bending a certain way? Is it because light is reflecting off the ocean and the water is blue? Is it because that's just what particles in our atmosphere give off? There's many different reasons. So observation first and then research. That's going to be our hypothesis from here on out. So to kind of give you some pieces of information, oops, I went too far, pieces of information here. So clearly when we start to make observations, we're going to then do our experiment. We're going to gather our research. We're going to gather our qualitative and our quantitative information. And then we're going to come up with our conclusion. So we'll do our experiment and then our data, our new information, our qualitative and our quantitative information. And then we're going to come up with our conclusion. What do we learn about it? And you'll hear me say this a lot of times in a CER. Our C is our observation and hypothesis. Our E is our experiment and our qualitative and quantitative, and our R, our reason, is our conclusion. And then we'll say, okay, well, does this best fit with this law, or does this best fit with the theory that we can kind of embed into what we've learned? So two big things that we're going to talk quite a bit about is our independent and our dependent variables. And you'll hear me talk about these quite a bit. And this actually can kind of connect to our algebra that we maybe have already taken or are taking right now. So if you think about a graph, you have an independent variable and you have your dependent variable. And so your independent variables in science are always the factors that are being tested, whereas your dependent is the factors that are being measured. So when we look at that on a graph, we're going to have our x and our y-axis. Let me get my whiteboard out and kind of draw it out for you. So we have our x and our y. So hopefully this kind of looks familiar here. Our x and our y. Our x is going to be our independent and our y is going to be our dependent, meaning that it depends on what's happening with our independent that's going to allow our other one to kind of measure through it. And then sometimes we're going to look at experiments as controlled variables, meaning that we know that sometimes if we run something and we test that over and over again in that scenario, it's going to be the same. How can we factor in change? So if I were to measure something with photosynthesis in a plant, clearly if I remove the sunlight from the plant, it's not going to grow as well because it needs that sunlight to produce the food in the process of photosynthesis. So there's a controlled variable. I'm taking something away, or I'm leaving one in the light because I know it's going to do well in the light, and then move one into, I don't know, a closet, a box or something. That's going to change the experiment. And I forgot to put that. Factors being controlled. No change between the different experiments. No. So here we go. Here's our example of a control group. Does not get the independent variable, whereas the experimental group is the control but gets the independent variable, meaning that group A is our control variable, group B is our experimental. And see, they gave you the information here. 200 milliliters of plain water twice a week for 3 weeks, 200 milliliters of fertilized solution twice a week for 3 weeks. So did twice, but they gave these plants fertilizer, and as you can see, their measurement is 32 centimeters and group A is just 18. So our control group, we know if we give plants water, they're going to grow. But if we give them fertilizer, this hypothesis says that maybe they'll grow more. And then our last thing that we always want to make sure we do is run an experiment a few times. And then sometimes I'll say, hey, we need to get the average of that so that we can see if our information is staying consistent. So we do repetition. So especially in the first couple of labs that we'll do here, you'll hear me say, well, measure it 3 times. And you'll be like, well, the book didn't grow. I know that, but I want you to get a good idea on how to measure and give quantitative information, that measurement of information.